Wildfire is one of the greatest threats our planet is facing. Destroying property and endangering lives. And in recent years, record-breaking blazes have grown to magnitudes that firefighters on the ground can't contain on their own.
A flame length of about 5 feet is all about a firefighter can handle. But oftentimes these fires that we see, we have flame lengths that are hundreds and hundreds of feet in length.
Every year there's more and more fires. Now the fire season seems to be getting longer and more destructive.
But now, a team of aviation engineers, led by former firefighter Dan Reese, is striking back against these overwhelming infernos. Enter the global Supertanker, the largest firefighting aircraft on the planet.
The global Supertanker is just amazing. It's the queen of the skies. It absolutely is a game-changing piece of engineering. When people see such a big, magnificent machine do what it does, one just can't help but stare at it in awe with your jaw drop going, my gosh, how can that happen? Am I really seeing this happen?
This unique jumbo jet is equipped to tackle the planet's biggest blazes. Capable of dropping the equivalent of over 400 bathtubs of liquid in 13 seconds. It can create a barrier that stops fire dead in its tracks. With a wingspan wider than the width of a soccer field, and 4 turbofan engines capable of producing 254,000 pounds of thrust. The Supertanker can achieve speeds of almost 600 miles per hour, allowing it to reach fires anywhere in the world within 20 hours. It's a vital tool for supporting the heroic firefighters on the ground.
Fire up the APU and turn on hydraulics 1 and 4. We'll get the doors closed, and then I can get this ground tower out of the way.
Okay guys, function test today, primary mission is we want to check all flight controls are normal, and drop system is normal.
At a high-tech facility in the Pacific Northwest, the Supertanker's chief pilot, Cliff Hale, and his crew are preparing the aircraft for a test flight.
Pre-flight checks are all good here. Weight and balance, how's the weight and balance look?
Half load on the left side, 80,000 pounds of water. Yep, everything looks good.
As the largest aerial firefighter on the planet, it's essential the Supertanker is always ready for action.
This is the only aircraft of this size and magnitude, and if we don't have it right, we don't have the systems installed and tuned, the aircraft is unusable. So this is something that we have to get right.
We'll treat it just as the real thing. Keep a sharp eye out. Okay, you ready to go do this?
Ready to do it.
The Supertanker's team has designed an incredible piece of engineering. But how have they repurposed a jumbo jet for fighting huge fires? How do you drop liquid in an unbroken line from hundreds of feet above the ground?
Our goal is for the material that we drop to rain in on the fire, impact the terrain and the fire where we want it to impact and how we want it to impact.
And what do you use to stop a raging inferno dead in its tracks?
It would be mind-boggling for people to see the rate of spread that these fires have the potential of having.
Okay, clear for takeoff. We'll make a left traffic, Supertank 944.
Today, the flight team, led by Cliff Hale, is taking the Supertanker up to test the drop system.
Set takeoff thrust. Thrust draft, toga toga. Gear up. Gear's coming up. And just make a nice long left-hand pattern. 1,000 feet to go. Go.
But in order to convert this 747 from a commercial airliner into a high-tech firefighter, its engineers have had to solve some significant problems.
So the challenges are infinite when it comes to building an aircraft this size. It takes, in the realm of years, putting the drop system together in the aircraft to make it work, meet the parameters for what we need to do on the ground for the firefighters. So how much can we drop? How do we choose how much we want it to drop? How fast we want it to drop? The challenges are many.
To overcome these obstacles, the Supertanker team can look to the pioneers of the past for inspiration. Engineer Dan Dickrell has traveled to Florida's East Coast.
Look at that. Wow. This is awesome.
To discover an aircraft that helped revolutionize firefighting.
This is the TBM Avenger. It's an amazing and iconic aircraft of World War II. And I cannot believe that I've got the opportunity to take this thing up for a spin today. It's gonna be amazing.
First entering service in 1942, the Avenger was designed as a torpedo bomber for the United States Navy.
Avenger 108 Quebec is ready, runway 18.
With almost 10,000 Avengers built in total, it earned a reputation as one of the U.S. military's most effective aerial weapons.
Okay, you all set?
Yeah, man. Good to go.
Okay.
Here we go. Oh, that was so smooth. Oh, this is a marvelous airplane.
Yeah, I love it.
Shortly after the war ended in 1945, this now iconic aircraft would be called upon to take charge of a new mission.
So in the early 1950s, California was hit with some of the worst wildfires on record. The ground crews were struggling to contain the fire, so an engineers began to look for ways to fight fire from the air.
The eventual solution would come from an unexpected source. Paul Mantz was a well-known Hollywood stunt pilot who appeared in over 250 films. And his work to convert his privately owned Avenger would change firefighting history.
All right, Terry, go ahead and open the doors. Doors open. Oh, that's cool. Paul Mantz, he took his Avenger and retrofitted it to become basically a fire bomber. He removed the internals of the torpedo bay and installed his own tank. It's made of plywood, and it was lined with a weather balloon to prevent the water from leaking out. He would fight the fire by filling his tank up with about 500, 600 gallons of water, and then fly over the fire and drop all of the water directly on the fire, suppressing it. It gave the crews on the ground a fighting chance, and it was a game-changing innovation.
But how did Mantz make his concept a reality?
And it was a very, very effective and innovative solution in an era that really, really needed it.
And what can today's engineers learn from the pioneering firebombing Avenger decades later?
Ready, drop.
Valves open.
When stunt pilot Paul Mantz customized his Avenger aircraft to help combat California's historic 1950s wildfires, he forever changed the way catastrophic fires are fought. In order to battle towering infernos rather than enemy troops, the Avenger warplane was creatively re-engineered.
Oh, wow. Check this out. So being up inside the torpedo bomb bay of the Avenger is an interesting experience because ordinarily this would be where the torpedo would go, but with a firebomber, this space is where the tank goes.
The 500-gallon tank was divided down the center into 2 compartments, allowing the pilot to drop a half load by opening one door or a full load by opening both doors.
Since the doors could be operated independently, it allowed for a controlled release of the water. So if some of the water needed to be delivered, one of the doors would open, that tank would be emptied, and then circle around, do it again. It allowed very flexible delivery of water onto a fire.
Armed with Mantz's water tank innovation, the Avenger played a key role in tackling the wildfires of the 1950s, paving the way for the aerial firefighters of the future.
And it was a very, very effective and innovative solution in an era that really, really needed it. Supertanker 944, a heavy base turn, your discretion, runway 32 right, clear low approach.
Okay, clear to the low approach, 32 right, tanker 944, thanks.
Today, the team behind the Supertanker has taken the technology that was pioneered by the Avenger and scaled it up to record-breaking proportions.
Cliff, I got throttles.
All right, thanks.
Chief Pilot Cliff and his crew are getting ready to put the Supertanker's drop system to the test.
She's all looking good now.
Chris, where you at?
System is armed, system is hot.
Thank you.
Thanks.
Almost 70 years after the Avenger's first firefighting missions, the Supertanker can carry a staggering 19,000 gallons of liquid, 38 times what the Avenger carried.
Ready, drop.
Valves open.
And the payload can be dropped in just a matter of seconds.
Okay, off the button.
Okay.
Valves closed.
Thank you.
It's an epic feat of engineering that no other aircraft in the skies is capable of. This remarkable operation is only possible thanks to the unique technology inside the aircraft's fuselage. David Allen is the head of maintenance.
These 5 tanks here that are on the left side, along with the 5 tanks on the right side, these are what hold the water or anything else that we're going to drop. Each one is independent, and the total capacity of the system is 19,200 gallons.
Each of the 10 huge liquid tanks was custom welded from aluminum alloy, the largest of which can carry 2,645 gallons.
Currently, there's no other aircraft that has a system like this. It's all internal to the aircraft. The major benefit to the internal system is we have no airspeed or altitude restrictions. We can fly any fire anywhere in the world at the same airspeed and altitude as a normal passenger aircraft.
In order to transform the Supertanker from its former passenger-carrying configuration, each of its 386 seats was removed from the lower deck, and an inventive engineering solution was used for installing the giant tanks.
Well, in order to install these tanks, because they're so large and they won't fit through a normal door, this entire section of the aircraft fuselage is cut out, and this and this cargo door section is put in.
With the liquid tank system weighing in at an excess of 16,000 pounds, the task of fixing them to the aircraft was difficult and delicate work. But accommodating the additional weight once the tanks were installed was another challenge.
Because the tanks are so large, the main deck cargo floor had to be reinforced. They take out the original floor assemblies and they install the beefed up floor structure that can handle the additional weight.
With the enormous tanks successfully loaded up in their reinforced aircraft, the team behind the global supertanker has created a firebomber of epic proportions. Operated by a crew of 15, the supertanker can dump in excess of 3,800 buckets of liquid in 13 seconds. It is capable of executing drops as low as 200 feet above the ground, meaning at its lowest functional altitude, it would almost scrape the top of the Leaning Tower of Pisa. On board the supertanker,
Okay, speeds are in.
Cliff Hale and his team are putting the plane through its paces. But these displays of daredevil flying aren't just for show. They're critical to ensuring that the liquid the crew dumps lands exactly where they want it to.
It's an incredible challenge to drop the product and be accurate with it. Your drop height's at 250 feet, but you might be crossing over ridge lines at 150 feet. Now, crossing a ridge line at 150 feet with a 747 is pretty amazing.
Not only do the pilots need to fly perilously low, they also need to fly at a slow speed.
Altitude checks.
But with the fully loaded aircraft weighing over 850,000 pounds, that's easier said than done.
If you're pointing downhill on a downhill drop, now you've got the weight and the airspeed that's pushing you, literally pushing you downhill. It's all very challenging.
In order to achieve this seemingly impossible feat of low and slow flying, the supertanker is equipped with an ingenious engineering solution.
So what we're looking at here is the Fowler flaps on the aircraft. They increase lift and they increase drag, so it helps the aircraft slow down for the drop. In typical cruise flight, these flaps retract up into the wing cavity, and as they come in for the drop and they need to start slowing down to reduce the airspeed for the drop, that's when they'll extend the flap stemp. When the flaps are all the way down, this will help the aircraft slow down to at around 130 knots or 149 miles per hour.
Fowler flaps expand to enlarge the wing's surface area, increasing lift. As they extend down, they increase drag, allowing the aircraft to stay airborne at slower speeds.
In order to take an aircraft this large and this heavy and to make it slow down to 149 miles per hour, you have to have a flap system like this. If for any reason we had a failure that the flaps were completely inoperative, it would be impossible for us to make a successful drop.
But skillful flying and specially designed wing flaps aren't enough to help the supertanker slow the spread of the worst wildfires. To combat the most volatile blazes, the team must engineer another solution.
You can have up to 90-mile-an-hour winds pushing a fire, burning several thousand acres a minute.
For inspiration, the global supertanker team will turn to the pioneers of the past.
Now this is pretty intense, even under these very controlled conditions. I can only imagine what this would be like if it was a real fire.
Wildfires are one of the most destructive natural forces on the planet. We rely on firebombers like the global supertanker to help fight these devastating disasters. But in the most extreme cases, even these technologically advanced aircraft can't completely smother the flames from above. It's a challenge the Supertanker's Chief of Operations, John Winder, understands from firsthand experience.
I've personally seen some pretty extreme fire behavior. You can have up to 90-mile-an-hour winds pushing a fire, burning several thousand acres a minute. They can be very, very dangerous for the public and for the firefighters.
Extinguishing such large and fast-moving fires from the air is almost impossible. So the Supertanker team needs to take a different approach.
We actually don't try to put the fire out. What we're trying to do is build containment lines, to give the firefighters a chance to get there.
By dropping lines of liquid ahead of the fire, the Supertanker can create a barrier that slows or stops its spread. But in order for this containment tactic to be successful, the crew needs an alternative to water.
Water, it has to be applied directly on the fire. Otherwise, it'll just evaporate before the fire even gets there.
To find a solution, engineers must look to the innovators of the past. At a state-of-the-art fire training facility in northwest England.
Okay, water on!
Water on!
Fire safety engineer Luke Bisbee is about to do a hands-on demonstration of the challenges involved in firefighting.
Another step forward. Okay, that's it, keep it low, there you go, calm down now.
Now this is pretty intense, even under these very controlled conditions. I can only imagine what this would be like if it was a real fire.
Take another step forward. There you go.
Okay.
When it comes to fighting fire, water has long been one of our most effective weapons.
Well, you can see what's happening here is that the spray from the hose is pushing the fire away from me, but also all this water spray is turning to steam. And in doing so, it's consuming energy, so it's taking heat away from the fire. And eventually, if enough energy gets taken away, the fire will go out. Let's cut it down.
But while water is a tried and tested means of tackling fire, there are some situations in which water is simply not enough.
Whew, that was intense. Now, sometimes if a fire is too hot or too big, we just can't supply enough water to put it out. And if a fire has an abundant supply of fuel, sometimes just as we extinguish one area, it's moving so fast that another area will ignite and the fire will spread before we can do anything about it.
It's a problem that has been plaguing firefighters for thousands of years. In the 19th century, French chemist Joseph Louis Gay-Lussac proposed an answer.
So what Gay-Lussac did was he formulated a mix of different chemicals that could significantly slow the rate at which a fire can burn. And the key ingredient in that mix was this stuff, ammonium phosphate. It's essentially a form of salt.
When combined with ammonium chloride and borax, the ammonium phosphate-based formula became known as fire retardant.
Now, our fire retardant is a more modern mixture, but the key ingredient remains the same. And I'm going to demonstrate how it works.
Created to help solve the problem of stage curtains catching fire in crowded theaters, Gay-Lussac found that when material was coated in his newly discovered liquid, it stopped the spread of flames.
So what we've got here is fuel. It's dry straw, so it's really flammable. And when I introduce this fire, you can probably guess what's going to happen. Now, this is quite a small demonstration, but you can imagine at the scale of a forest that a fire spreading rapidly through the forest The firefighters would have no chance to put that out with the water alone, and so they'd need another tool in their arsenal.
Just like on the Supertanker, retardant can offer fire crews an ideal alternative to water.
Now let's see what happens if we repeat this exercise, but in this case, I've treated a line of fuel with our fire retardant. We can see the fire now is really taking off and it's spreading across the fuel. And you can see the flames licking at the patch that we've got treated with the fire retardant. This is really amazing. You can see that the fire has just stopped at the line of treated straw. The fire has been stopped dead in its tracks.
It's an incredible result. That's all thanks to the chemical properties of the retardant's key ingredient.
So what's happened here is that the fire has burned along the tray until it meets the fuel that has the ammonium phosphate. When ammonium phosphate is heated, the molecules break down and consume the energy. And so that energy is no longer available to burn the fuel, and eventually the fire just goes out. The fire retardant doesn't actually extinguish the fire, it prevents the fuel from burning.
Long after Gay-Lussac's discovery, retardant is still an essential part of the firefighter's arsenal.
This is really incredible stuff. A brilliant invention that gives fire crews another vital tool in their never-ending battle against fire.
Today, the Supertanker depends on this innovative liquid to help battle the biggest blazes. Gay-Lussac's fire retardant is a powerful tool, but it still needs to be meticulously deployed to be effective.
Because of the large capacity of chemical that needs to be delivered, it becomes a challenge.
To give the global Supertanker aircraft its best chance to fight the worst fires, engineers will need to utilize another pioneering innovation of the past. When chemist Gay-Lussac invented retardant, it became crucial in the ongoing fight against fire. And it's a tool that the global Supertanker team relies on.
Retardant can be very effective. It's the ultimate tool, certainly on large, rapidly expanding fires. We're not dropping right on the fire, we're dropping ahead of the fire. The hope is that you have enough retardant down that you can slow the fire long enough that the ground resource can get in and actually put the fire out.
And it's not just its firefighting properties that make retardant such a useful substance.
The red color gives us the ability to see it from the air. You can start to build a retardant line. Firefighters know when they come upon it, they can smell it, see it, and feel it. If you're on a ridge looking across, you can start seeing they've got retardant in place, and that may play into your decision process of what you're going to do as a ground firefighter.
Fire retardant might help stop the spread of fire, but to use it effectively, the Supertanker must drop thousands of gallons in an unbroken line.
Any gaps in a retardant line is an opportunity for the fire to burn through.
I'm just gonna go down a little bit. All right, you guys ready?
Ready.
As Chief of Operations for the Supertanker, John Winder understands the challenges of achieving this seemingly impossible feat better than most.
So when you're laying a retardant line, the rule of thumb is that you always overlap each drop by 20% in order to ensure that you don't have any gaps in the line.
Any uneven coverage of retardant on the ground will allow the fire to keep spreading. But accurately dropping thousands of gallons of liquid from hundreds of feet above ground is not a simple task.
You got to control the retardant at a precise amount and timing to get the coverage level. Because of the large capacity of chemical that needs to be delivered, it becomes a challenge.
To find a solution, the Supertanker's engineers must look to the pioneers of the past. At a remote airstrip in the Midwest, pilot Michael Rutledge is preparing to take to the skies in an iconic aircraft.
As we have to pull it through.
The Stearman Model 75 was built in the 1930s as a training plane for the U.S. military.
So we've got it warmed up enough now. All right, beautiful day here in Iowa today.
Between 1934 and 1945, around 8,500 Stearmen were built, and more American pilots were trained on them than on any other plane.
It's an easy airplane to fly. It doesn't take a lot of skill, but to fly it correctly, it takes the appropriate technique. Originally, it was outfitted with an underpowered engine of no more than 220 horsepower, so things just didn't happen fast while the student pilot was learning all the intricacies on how to fly the airplane.
But once the war was over, this formerly essential aircraft was in danger of becoming peacetime surplus. But while the fight against the Axis was over, a different fight was brewing at home.
A 100-acre field could be sprayed and treated in a matter of minutes rather than a matter of days by ground crews.
One that would change agriculture forever and inspire the team behind the global supertanker to engineer the impossible.
It's exhilarating, but it demands a high degree of situational awareness.
Pilot Michael Rutledge is in Iowa to see how a former military training plane became crucial in the fight against crop-ravaging pests. And this agricultural innovation may hold the key to making the global supertanker the most effective firefighting air tanker ever.
So after World War II, the military didn't need trainers for warplanes anymore, so Stearman could be had for as little as $250 for the full tank of gas, and they were opened up to the civilian public to use for whatever they wanted.
But an industry in crisis would offer the Stearman a new lease on life. In the late 1940s, the Cotton Belt was ravaged by a plague of vermin. With crops covering an area equivalent to 3 times the size of Belgium, applying pesticides by hand was too slow to stop the outbreak, leaving farmers facing ruin. Conrad Barlow, a farmer and engineer from California, proposed a solution to protect the cotton.
So Conrad's system enabled aircraft to distribute all the product and insecticides and pesticides at a much more efficient rate. A 100-acre field could be sprayed and treated in a matter of minutes rather than a matter of days by ground crews.
Barlow's innovative design transformed the Stearman from training plane to crop duster.
So this is a hopper. It's 200 gallons of fiberglass. They did remove the front cockpit to put this in, and they just dropped the hopper in and then bolted it in place. So this is where the liquid is loaded into. It's just a steel hatch, and they would just put the hose in, and they just loaded everything into the hopper from a top fill. That 200-gallon hopper then gravity feeds liquid into this centrifugal pump, which is driven by this propeller. It's a very, very simple system. That propeller drives the centrifugal pump. That pump pushes the liquid through the tubing, and then that pressurizes it out to the booms. So when the product gets pressurized by the pump, and it's still pressurized at approximately 40 psi, it comes into these nozzles, and each one of these nozzles is evenly spaced to provide an even spread of the product, and it just comes out of these nozzles in about a 400 micron spread onto the crops.
Almost 80 years after Barlow's liquid spraying innovation, the aerial application of pesticides is as important to agriculture as ever. With many modern aircraft still relying on pressurized spraying technology. But in order to make the most of this airborne innovation,
all right, here we go. Coming in for a run.
it takes a pilot of great ability.
It requires a lot of precision and skill because you're routinely flying 10 to 15 feet above the props like this at 120 miles an hour.
It's exhilarating, but it demands a high degree of situational awareness.
Thanks to the pilots that flew them and Barlow's air pressure technology, the Stearman helped prove the power of liquid spraying.
Crop dusting as we know it today wouldn't exist had it not been for the advent of the Stearman and its impact on the industry.
In the skies above the Pacific Northwest,
Take 944. You're clear to land.
Thank you.
Cliff and his crew are bringing the supertanker safely back to Earth after a successful test flight.
Flaps up.
Flaps up.
Their mind-blowing drop operation was only possible thanks to engineering inspired by Conrad Barlow's pressurized air technology. But Barlow unveiled his innovation decades ago, and the global supertanker is a 21st century marvel.
The air tanks, they were hand-formed, hand-welded, and specially built for this aircraft. You can't buy these off the shelf.
To create the most effective aerial firefighting tool ever, the team will need to take Barlow's invention and supersize it.
Absolutely the most amazing aircraft that's flying in this current day and age. It's just an amazing machine.
In order to tackle the biggest wildfires on the planet, engineers have designed a firefighting aircraft on an epic scale. This is the global supertanker. This 747 jumbo jet has been custom designed to help firefighters on the front line tackle the world's worst blazes. Inspired by Conrad Barlow's 1940s pressurized crop dusting innovation, this aerial firefighter can carry a whopping 19,200 gallons of liquid and drop an unbroken line of retardant that's over half as long as Mount Everest is high.
Right now we're in the aft section of the aircraft, and this is where the retardant system stops, and this is where the air system begins. The air system is what pressurizes and moves the retardant out of the aircraft. These are the 8 air tanks that pressurize the aircraft system up to 185 psi. The air tanks, they were hand-formed, hand-welded, and specially built for this aircraft. You can't buy these off the shelf. When these tanks are fully serviced, they'll hold 1,634 pounds of air alone.
In order to push retardant out of the supertanker, pressurized air is first released into the ullage tanks and #1 retardant tanks, compacting the liquid inside the system. When a valve is opened, the air begins to move through the tanks, forcing the fluid out. As the retardant flows out, the valve opens wider to maintain constant pressure and ensure consistent ground coverage. But unlike the Stearman with its wing-mounted spray booms, the final component of the supertanker's drop system is embedded in the aircraft's underbelly.
So what we have here is our 4 16-inch drop tubes. So depending on the coverage level that we need, the drop system operator will select 1 to 4 valves. If you have all 4 valves selected, you can actually dump the entire 19,200 gallons in about 13 seconds. To really put that in perspective, if you had an average size swimming pool at your home, we could fill that swimming pool in 13 seconds. It's something to really be proud of.
The engineering behind this incredible aircraft has allowed it to achieve the seemingly impossible and change the game in the fight against wildfires.
I would say the Supertanker is absolutely the most amazing aircraft that's flying in this current day and age. It's just an amazing machine.